All right, this is the Walk Lab. So the first thing I'm going to do is I just hand sanitize my hands. We're going to be outside, but we're not really going to be touching the equipment, but there is some equipment that we just want our hands clean for. So the purpose of this lab activity, you practice finding the average speed of a person doing various activities. So the directions: use a stopwatch on your phone and the measuring tape in the hallway or outside to measure how far you'll go in 10 seconds. Record your data in the table below. Use a timer and the measuring tape in the hallway or outside to measure how long it takes you to go in 20 meters. Record your data in the table below. So, 1. The measuring tape is used to measure length. What is the resolution of the measuring tape, and does it have an uncertainty digit? Why or why not? So you have to look at this measuring tape and you have to tell me, well, what's the resolution, and if it has an uncertainty digit, why or why not? Now, the stopwatch on your phone is used to measure time. What is the resolution of the stopwatch on your phone? Does the stopwatch on your phone have an uncertainty digit? Why or why not? Now, the next question is, when dividing measurements, what determines the number of significant figures the result has? How will this affect how the results are recorded when you calculate that speed? And is the following a scientific claim? Why or why not? Now remember, for a claim to be scientific, there must be a test for something. Skipping is faster than any motion where one foot is always on the ground. So next one is, make a hypothesis. Write your hypothesis. Be specific as possible. Now remember the rules for a good hypothesis. All right. So the next one says, use a stopwatch and the measuring tape right here to record various activities. So the activities are going to be walking, backwards walking, speed walking, and skipping. So you're going to walk this length twice. So you're going to do it once, time yourself how far you get in 10 seconds. So you have somebody start a timer for 10 seconds, get down there. Then what you're going to do is there's a 20-meter mark. So that's marked by that yellow placard down there. That's 20 meters. You're going to time how long it takes that person to get to that 20-meter mark. Then you're going to do that again for backwards walking, speed walking, skipping. Then you're going to calculate the speed of all those trials. So all in all, there should be 8 trials. Then for the walking, you're going to have 2. You're going to have one where you had the time, one where you had the distance. You're going to average those to get the average speed of walking, backwards walking, speed walking, and skipping. Then on the conclusion, you're going to identify the independent variable, the dependent variable, and 3 constant variables for this experiment. And the next one is, was your hypothesis wrong? Was there a significant difference in the speed of the person skipping when compared it to the motion with one foot on the ground? If your hypothesis wasn't wrong, does that make it right? Explain your answer. So walking, backwards walking, and speed walking, there should always be 1 foot on the ground, at least 1 foot always on the ground. Now skipping doesn't. So in all of the trials where the speed was calculated, were these instantaneous speeds or average speeds? Explain your answer. Now, all motion is relative, and in order for speeds to be determined, a frame of reference needs to be established. When measuring the speed of the toy, or the person that was doing this, what was the frame of reference? Why do you think the frame of reference didn't need to be established in the directions? The next question is, identify any random errors that were or could have been in this experiment. Did the random errors affect the accuracy or precision of this experiment? What was done to mitigate the random errors in this experiment? Next one is, identify any systematic errors that were or could have been in this experiment. Did the systematic errors affect the accuracy or precision of this experiment? What was done or could have been done to mitigate the systematic errors in this experiment? And that last question. So calculate how long it would take the person doing the activities to skip a mile, which is 1,609 meters. So use that equation, and you know the speed, you know that distance, calculate how long it would take. So last thing I'm going to do is just sanitize my hands just before, so I don't take any germs back to my desk. And once again, this has been the Walk the Walk lab activity.